right. Hello, everyone. I'm not sure if you can see me. Hopefully you can. Welcome to Cafe Sci. We're going to take a couple minutes, let people kind of get loaded into our room here. As you can see, I'm in one of the famous cafes. And if you think you have any idea what it is, you can drop it in the comment, or I'll reveal it later at the end before we finish up. So let's just give people a couple more moments before we kind of jump into today's Cafe Sci, which is sponsored by PPG and Cook Myosite. So thank you very much, PPG and Cook Myosite. And today's lecturer is going to be from Doug DeHaven. He is the exhibits designer mechatronics at the Carnegie Science Center. And so mechatronics is a word that I can barely say without tripping over my tongue, let alone define for you all. So it's going to be interesting for Doug to be able to kind of jump in and explain exactly what he does and how all the moving pieces come together. There's a lot of things that I haven't really thought about behind the scenes with some of my favorite exhibits at the Science Center, and Doug and the design team do a really awesome job at, getting these ideas and turning them into real life. And so using STEM at its best to balance creativity with informal learning. So this is awesome. All right, cool. So I think that we have some people loaded into here. We'll give it a couple of more minutes here. Like I said, this program is sponsored by Cook Myosite and PPG. Also, we want to thank you all for joining us today. This is our first virtual Cafe Sci. So as with all of our first and working from home experiences, please bear with us. Please give us feedback and let us know how this worked. With things we may be able to tweak. We definitely value your opinion and want to make sure that we can give you the best experience possible. So as we do a socially distant version of Cafe Sci, we still want to make sure that we have the same feel and flavor as what you're used to. And so if you see me looking over a bunch, I have a bunch of different notes and just making sure that we stay on track here today. And I'm going to take a bunch of notes about Doug's talk. I'm super duper interested in what he has to say. And, I've got a little preview of what's going on, and I don't want to spoil so much for you, but there's some really cool things and some behind the scenes stories about how some of the exhibits come together at the Science Center, which is really cool. All right, and so I'll introduce Doug here in 1 second here. But if you've never been to a Cafe Sci before, and being that this is our first virtual Cafe Sci, let me just kind of recap what's going to go down. So we're every month on the very first Monday of every month at this time, 7 p.m. We host Cafe Sci, which is our virtual web series that deals with different science topics. Each month you can come and log in and ask some questions to a science expert and hear a really awesome presentation. After the presentation, we open it up for a live question and answer session. So if you have any questions about what you've seen or what you heard, feel free to drop those in the Q&A section here. You can drop your questions in at any point. Doug is going to kind of go through his presentation, and if for any reason he doesn't answer your question during his presentation, we'll go back to all the questions and make sure that we get to you. All right, cool. So without further ado, I'm going to go ahead and introduce Doug DeHaven, the exhibits designer mechatronics at Carnegie Science Center. Doug, are you with me?
I'm here. I'm down here by the PPG logo. Hopefully everybody can see me down here. So again, I'll just give it a few more minutes. Thank you for the wonderful introduction, Lamont. This is my first Cafe Sci. I've been to many of them, but never as a speaker. So this is a wonderful opportunity. So I thank you guys for that. And one thing I want to take some time to talk real briefly while we're waiting for some people to get settled in here. First, hopefully you guys got some food on the lobby on the way in, if you've been to a previous Cafe Sci. So what we're going to do here is, you notice I'm kind of small and I have a nice white background behind me. I'm using software called OBS. Open Broadcast Software. It's free software, and it allows you to use green screens, take your webcam, composite the image, and you can export it as a virtual webcam into things like Zoom or other meeting softwares to get a more dynamic interface. Speaking of which, I guess we should move on to the talk here. So today's talk is going to be building the massive wall of buttons. So hopefully we got everybody in the room, and we're going to get started here. First, you need to see my shining face. Hello, all. My name is Doug. I am mechatronics here at the Carnegie Science Center. And before we go into the button wall, I kind of want to explain a little bit about that title, because it's kind of a new vernacular term. And we're going to get going here. So my title, like I said, is mechatronics. The mecha part is mechanical design. The trony part is electronics design. So that comes down to doing component level stuff. The CS is computer science or programming. So it is the merger of all of those sciences. And I would take one moment here, being this is a prototype talk. I just want to mention Lamont, I believe I can still hear an echo slightly. So, So we're going to move on from there. So we have this logo here, and this kind of fills in what all the aspects that I do, combine the electrical, the computers, the mechanical, all into one world. This wasn't really needed back in the day. I remember when I was in school, I asked my computer science teacher, I said, hey, how do we talk to external devices? He looked right me in the face and said, you're never going to need to know how to do that. So the world has really changed, and the aspects of it have, and you needed someone in design who could do these aspects. I work part of a team in our design suite, 3 amazing people. We have Brian, who's our lead exhibit designer. He designs what the function of the exhibit's gonna be, how it's gonna look, does the blueprints, the material science on how that's all gonna work together. We have Azure, who's our head of graphic design. She does the look, the feel, the colors, the fonts, and the text panels. So I work closely with them to combine it with how it's actually going to work, the form and the function. So we kind of enthrall all parts of STEM into mechatronics, which is really cool. And I'll get into that more later. But basically what this all means is I build robots. I was a key part in building RoboWorld. It's now going on almost 11 years now. And what's cool is here I am in my robot repair shop, as I like to call it, or the electronic shop. This is Quasi the robot, who is part of one of our planetarium shows at the Buell. So make sure you stop down and check out one of those shows. I was just working on some of the servos here. Robots are a great way of tying in what mechatronics is all about. You have servos, you have mechanical joints, you have material science, you have the mecha part, you have the electronics part, you have the power supplies, the servos, the parts that are the electronic interface and the lights, the screens, the cameras. And then you have the computer science, which is the programming that brings all of that alive. Really cool thing, you can see me sitting here in the shop working on him. So every day is always an adventure, which I'll be getting into here shortly. So this brings me to my personal life. Here's some snippets of things I'm interested in. I've done high voltage stuff. I've done fire bending, as you see on the right there. The bottom left is a chamber I built. I did talk about this a few years back, that does the 4 states of matter simultaneously. So solid, liquid, gas, and nitrogen, or plasma of nitrogen all at the same time. I had frozen nitrogen plasma going on at the same time in a vacuum. It was really cool talk. On the bottom right, you can see that I'm into mechanical devices. And in the top center, I even built my own CNC plasma cutter, made myself my own batarang. So I embody mechatronics at home. So it's kind of cool to be able to do it for a living as well. It's lots of fun. But the reason you guys are all here is we want to talk about the button wall. And what better person to take it away, well, than myself. So I'll take myself away here. A 200 button wall, all built and controlled by an Arduino. So there are 200 HAP buttons, as you can see here, running down the wall. Inside the wall, there are multiple Arduinos doing the interfacing. So there are 200 different sound effects. You can, hi there. So you have all these fun sound effects. They play in different zones throughout the room. There's a giant tree here. They'll play church bells. You press this button, cause a thunderstorm, and you get lightning and thunder in that area. There's a submarine. If I can find the sound, it lights up a water effect over on the submarine. It also plays in there. There's also a farm over there where you can play different farm sounds. It plays over there. And then the ball factory here, there's this button. If I press that red button, it releases the tomatoes. And then over here, this button sends bubbles out of the wall. So the way this, I mean, it's a fun thing. The way it all works is, I'm going to stop it there because what will be the point of this talk. One thing I want to mention too is I tend to talk very fast. So I have a note here that reminds myself to talk slower. My apologies, I get so excited about talking about these topics. So I'll try to keep it calm. Fun thing about working on this wall is I started to remember out of all those 200 buttons, what did what. You kind of get involved in these things, it gets pretty crazy. But before I get into all of that, well, we got to go back to the drawing board. I got to show you where it all begins. Well, that starts with a design meeting. And a design meeting is basically where we throw a bunch of ideas at the wall and see what sticks. Now, the fun thing about a design meeting is everybody has an idea on what direction the project should go. And you're always stuck in the middle trying to figure out how you're going to make it work. Now, there's always people from other departments that we bring into our design meetings because we have a grand topic. Like we wanted to do the early learner space on our 4th floor. We wanted to revamp it. So we needed ideas from multiple people, multiple disciplines on things that they'd like to see. Well, for almost 10 years now, we've had this one lady, April, who has wanted a button wall at every meeting. She brings it up. Sadly, we never could take it on, but this project we knew with the early learners involved, what better opportunity to build her button wall. So I'm sure she was very happy to hear that we decided let's build a button wall. And we moved on from there. Now, this normally takes us to the napkin sketch stage, where a lot of times the exhibits start literally on a napkin. This particular meeting was a little bit more formal, and it was drawn up on the whiteboard. So I tried to kind of recreate what the original design looked like from that whiteboard, and it was just a rectangle with a bunch of buttons on it. Now, we didn't know how many at the time. We figured 200 was a nice round number. Why we chose 200? Don't really know. It just sounded good. Well, that number may come back to haunt me later, but this is an idea of kind of how we're going to go about just the basic form of what it was going to take. So from there, I had to see if it was possible. Now, normally when you're building multiple buttons into an exhibit or into any electronic project, you usually use something called a matrix, which you have rows and columns of wires. And it can detect which row and which column to detect what button you've pressed. It uses less inputs on your controller, and it works really well. The problem is when you have something like hordes of kids pushing multiple buttons at once, it gets confused on which button is being pressed. I wanted to be able to read every single button individually. Well, with 200 buttons, finding a controller that could read 200 inputs, well, it wasn't going to be easy or cheap. So the first step I went into was going the Arduino route. Now, an Arduino is an amazing little device. It's a microcontroller. Think of it as a mini computer. You put simple instructions onto it, you program it, and it takes out those tasks for you. So what I did is I picked up a bag of Arduinos. You could buy them in bulk. They end up being really cheap. And I decided, let's try to communicate across them. First thing I figured out was how I was going to interface with the buttons. Each Arduino can do roughly 16 input-output pins. So I knew 10 buttons would be a good number for each Arduino. And they scale well. We count down 10, 20, 30, 40. So what I did is I used the 10 pins from 1 to 10 as my input pins. And then on the other side of the Arduino, I handle the communication. Well, the communication was something I had to figure out how I was going to do. It needed to be simple, robust, and it needed to be with minimal components, because when you start multiplying things times 20, costs really build quickly. So what I came upon was the I2C communication. This was developed, I believe, early on for television use, for the different components inside television to communicate with each other. So I figured it's a perfect application for that. Also, early electronics and computers used ribbon cable to send data. So I'm like, all right, there's reasons for this. People have figured all these problems out before. There's no point in reinventing the wheel. So if you look on the left picture here, you'll notice that I have a very thin ribbon cable. This was the bare minimum number of pins I needed for power, ground, and the 2 communication pins. Now, I set this all up and I was using larger headers, which I'll show you in a moment. And the problem trying to get that smaller ribbon cable lined up perfectly in a larger header, it wasn't perfect. I got about 10 down, it started to drift. And if I drifted too far, I would short out all 20 Arduinos at once, which I didn't want to do. So if you noticed on the right side here, I went with a wider ribbon cable, the full width of the header. This fixed all those problems. The thing I was crimping on for the connectors all went perfectly. So you see here in the next photo, this is the connector I was using. It's very similar to the old IDE connectors on hard drives from computers. And I used 1 row of those pins to interface with the Arduino to plug it in to send the communication and power across all of those lines. Now I left the left side of the Arduino open because those are my input pins, which will get a different header to go on. Well, I needed a way of kind of holding this all together. So we have a partnership with a local program called the Fab Lab. It's a shop in our Sportsworks facility. It's open to the public. They have workshops. You can come in, you can learn how to use laser cutters, CNC routers. You can use 3D printers, vinyl cutters. There's so much you can do there. I highly recommend going down, taking a class, learning some of the equipment. We have a partnership with them, like I said. So I went down, drafted up a bracket to hold everything, and cut it all out on the laser cutter using acrylic. That laser cutter and acrylic is an incredibly good staple for us here at the Carnegie Science Center when we're building exhibits, because it allows you to build these one-off items quickly. So I went upstairs, hooked it all up, and the scale was wrong. Whoops. Now, you always hear those jokes about how NASA misses a planet with a probe because they're off by order of magnitude or a conversion. Yeah, well, that's what I did. When I was moving between software, because FabLab uses slightly different software, my order of conversion was different. And you notice the scale is completely wrong here. So you learn from your mistakes, you move on. Like I said, exhibit development is a very iterative process. So went and redesigned the second set of brackets. And you can see here, they work perfectly that time. And you now see a colored rainbow ribbon cable, which is a fun word to say. Those are now my input pins on a second header that plugs in the left side of the Arduino. So the main data and bus passes under, the second one picks off and goes up. So this is a way of interfacing the X and the Y through all the Arduinos and allowed me to screw it down to the board. So from here, I went on Amazon. I ordered basically all the colored rainbow ribbon cable they had and started laying it out into the wall to get a feel for how these buttons were going to lay out. So from there, we moved on to getting those out and then figuring out the first row of buttons. Now, these may not look like normal buttons. These are made by a company called Suzio Hap. They're arcade buttons. So if you've ever been to an arcade and played a game, those are the buttons they use. They're incredibly durable buttons. We love them at the Science Center. They really hold up well to kids mashing them. So I set those up. The only problem with these buttons is the interface is not easy to do en masse. So they make buttons that have sockets you can just plug in. Those would have been ideal for a system like this, but they're not reliable. So we went with these, and they all have spade connectors. You'll have to crimp connectors on and put them on. So if I was doing this, I wanted a way to make sure I could minimize the amount of effort, time, and material that went into creating this. So I created my first row of buttons. And you can see a bus that runs down there, which I'll explain later. And then the ribbon cable branches off to each individual button going down the line. So this brings me to a video series. So at the Science Center, I do a lot of videos just for fans who want to know the behind the scenes of what goes on. These normally don't go through the official Science Center channels for social media. We're working on that. So if there's interest in this, feel free to let us know, and we can do this more officially. But I have other means in which I share this, so feel free to reach out to me. I can share these videos of other projects in the works. But again, I'll let myself take it away here.
Hi, Doug here. So I want to give you an update on the button wall project. So we covered in the last video all the Arduinos going down here. So I have one coming off now. This rainbow cable goes down. You see it branches off for each button as it goes down for each input. And then to power the lights on the button, I'm using this very long power strip here wired into the 12-volt rail. So I'm using it for 12-volt distribution. Runs down to these fun little clips here that branch off to power it. So common 12-volt rail, and it shares a common ground with the power supply. So you'll see the buttons are all lit up. When you press it, the light goes out.
191.
And it reads out the input. So if I press these,
191, 192, 193, 194, 195, 196.
so on and so forth. And you can mash these all you want. You can hold two of them down.
192.
And it keeps up with that. It works out really well. So there's only 1,800 terminations left to go to get all the buttons wired in, but you have to stay tuned for that. So thanks for watching.
So that was a fun video series that I did, and I enjoy doing this for other projects, which I'll be getting into in a moment. So this brings me to testing the mechanics and the code of everything. The coding got a little complex, believe it or not, because I'm communicating with those 20 Arduinos and trying to keep track of them, and I need them to work in almost real time. When you press that button, I want an immediate response from it. I don't want a delay. And I looked at something called shift registers. Guys in electronics will be familiar with these. It's basically a smart way of expanding inputs and outputs from a single controller. And you shift the data in and out in long chains of data. Believe it or not, on a button wall this size, you're looking at over 3/4 of a second to get a response from a button press with that many data in the stream. So this system was a unique way of approaching, again, this unique problem that we had. But here I'm going to show you this video where I'm testing each button by touching the wires on the Arduino.
2,
And if you notice,
4, 5,
you hear my
6,
voice saying a
7,
number,
8,
and you see a number on the screen.
11, 12,
So what I did is I spent an
14,
entire afternoon sitting in front of a microphone, and I
16,
recorded myself saying 1 through 200,
20,
200 times as individual MP3 files, loaded them onto an SD card,
22,
and put them in my
23,
controller.
24,
So when I
25,
press that input,
26,
the screen
27,
shows what number
28,
it thinks you've
29,
pressed,
30,
and then the audio clip tells you what actual audio clip it played. This is a way of me
31,
verifying that everything synced up
33,
and everything was working
37,
properly.
40.
So from there, we wanted to build the main electronic interface. So up here, you'll see the row of Arduinos that we talked about earlier. That comes up through this ribbon cable and breaks out to the one Arduino that I call the master. This one handles all the communication across the entire I2C bus. So what it does is it sends a command down the line and says, number 1, do you have any information? Number 2, do you have any information? This works a lot like a postman going down a single street. Each house has an address. The mail only goes to the house with the right address on it. That's kind of the way this works. Now, the data passes through all the Arduinos, but they only listen for their address and what information is associated with it. So the master controls all that. Now, what's nice to speed things up is if the Arduino has not seen a button press, it ignores the command and the master moves right past it very quickly. If it did have a button press, it remembers it and sends it off to the master to say, I've had this button pressed. Once it does that, it clears the memory in that Arduino and it's ready for the next button press. The master takes that information and goes, all right, I've had button number 3 pressed. What do I do with that? First thing it does, display it on the screen. Good for troubleshooting and prototyping. From there, it moves down to these main controllers here. And these are Adafruit Sound MP3 modules. They're Music Maker series. And amazing company, Adafruit, if you ever checked it out, if you're into electronic work. They build these beautiful boards, some of the best Arduino controlled music players that you can get, at least in my opinion. So we put in multiple zones here. And the reason we did multiple zones, we wanted different sounds to play for different amounts of time in different areas. And that was the best way to approaching multiple zone audio. And at the end here, we have a DMX board. DMX is basically a fancy form of serial communication that's for industrial light and like DJ use. I needed a way of interfacing with commercial equipment in the room to talk to it and do dynamic things with it. So that was that interface. And then at the bottom down here, I have a row of relays to talk to the quote unquote stupid stuff in the room. If I need to activate relays or lights or triggers, that's what that was for. So these all communicated through the I2C bus, which you can see linked here, which is just power, ground, and the 2 data lines. So from there, it brought me to a very interesting conundrum. I needed a way of testing the equipment in the morning to make sure that all of the zones were working and each independent soundboard was playing properly and in the right area. So well, I'll let you see what I did here.
You go, no go for launch. FAO.
We are go.
Network. Recovery. Capcom. Launch control, this is Houston. We are go for launch.
So some of you may recognize that from a popular movie, but what it worked well for was each zone would respond back with, yeah, I'm good. And then once the wall finishes doing that, all the button lights come on and it's ready to go for the day. The sad part is no one ever experiences this because it only happens when you first power it on in the morning. There's no one ever there. But knowing in my heart that it's there, I love these little Easter eggs. I try to put them into exhibits because it makes the job fun and entertaining. And it's a practical use to let me know that everything's working in the morning. So this brings me to the time we're now starting to renovate our 4th floor. So the earlier space that was up there had to be ripped down and we were going to make way for the new one. Now, normally as a visitor or a member, this is what you would see. You would see a curtain put up, some fencing to keep the kids out of the construction area, and you hear a bunch of noises and you just kind of wonder what's happening. Well, that's not the point of the talk today. The point of the talk today is to take you behind the scenes. So let's jump you over that curtain and show you what actually goes on behind there. So here you see what's left of the early learner space that was up on our 4th floor. In the middle was a large stainless steel water table that we had. And then the side there was a construction area. And then we also had a ball factory. So it was lots of exhibits that big that we just had to pull out. We even had to jackhammer all the concrete out of the middle, which was a big project. Now, I jumped ahead here, but the fun part about removing all these exhibits is the things that you find underneath of them, things that have been lost for decades. Kind of a gross procedure, but it's amazing to see. It's almost like exhibit archaeology. Now, this brings me to the point where we're pulling out the exhibits we don't need, and you can see the carpet's been ripped up. We're kind of sanitizing the space both physically and mentally. Seeing an open floor plan like this, it helps you visualize what the new exhibit's going to look like or how it's going to work, and also let you know if the physical blueprints you've drawn work in the space. And it's a good opportunity too, when you're starting to remove old exhibits, just to have fun with them. I mean, where else are you going to have an 8-foot tall toothbrush? We ended up donating this, which the group that got it absolutely loved it, but it was just the fun things you come across working day to day at the Carnegie Science Center. So this brings me to the space now in mid-renovation. You can see on the left here, this was a kitchenette area. This is where we would clean all the balls, the toys, the stuffed animals every day at the Science Center to keep them sterile and clean for the next kids who come through. Now, this area had to be changed because, well, we had to make room for this new button wall. On the right side here, see this gentleman here, Brian Abraham. He's our lead designer. He's laying out one of his blueprints physically in the space, which is the outline for our water table area. So he's just trying to get a feel of what it's going to look like as well as where the floor finish is going to end up. So speaking of floor, some of the fun things is you have to make the building adapt to the exhibit. Now, our water table area needed a drain for it to work properly. Well, we have concrete floor, so we had to do something called a core drill. So we brought in a core driller, which is basically a giant hole saw that's pumped with coolant water, and it just runs slowly down through the floor. It uses a vacuum to hold it to the concrete so it can apply a lot of pressure, which is really neat. You see on the right here, there's a cross section of the floor at the Science Center. You notice there's a big hole in the bottom. It's because we use cellular concrete. It's a structural shape that's a sphere or circle that allows for weight savings and high strength, which makes it fun when you're trying to anchor exhibits into it. But here we are putting the drain in for that. This brings me to the wall. This is now the adapted kitchenette area, and this is the new wall area for the new button wall. So at this point, project's starting to become a reality. Here it is all painted up, ready to go, in a lovely shade of science green. And on the left there, you can see the carpet going in. Carpet day is always an interesting day because you're playing musical chairs because they need access to the whole floor. So you're constantly moving exhibits around the carpet guy while he's trying to lay it down. And they're also putting this glue tack down. It's like sticky glue on steroids. And they have to let it cure before they put the carpet down. Well, if you're not paying attention and you're in a hurry and you go trucking through the space, it pulls your shoes right off. It's an adventure. So carpet day, we usually leave the guys alone and let them put the carpet in and get that all taken care of. If you look over on the right here, you'll see that the flooring, the epoxy flooring, start going in for the water table. So I always joke, whenever you work in exhibits at a museum, you're never doing one thing at once. There's always a multitude of tasks constantly vying for your attention. So this button wall was no exception. I'm working on that. There's multiple projects going on simultaneously. So I like to think of myself looking like this when I'm doing all that, but most of my days look like this. There's just so much happening. Sometimes you just have to step away and concentrate on one topic. Well, that brings me to the topic of the day, which happened to be, we're building a new addition on the Science Center. This is when the Science Pavilion was being constructed. Now, the contractors were building it, which was wonderful. My role, though, was in the AV specialist part. So I had to design and lay out the speaker system for our Point View Hall special event space, had to lay out the projectors and the screens, the AV rack, the digital media interface, as well as the smart classrooms, all the TVs interfacing for the laptops and the screens in that space. So I had multiple avenues that I was working in that space simultaneously while working on this button wall. The cool thing about doing these kind of projects is you get these close-up views of the construction and the process of these things being built. It's a wonderful experience. Now, speaking of construction, for those of you who are members and visitors, thank you for putting up with us during this time while the entire building was under construction. This is the main lobby, believe it or not, the Science Center, completely being renovated. And we're working on changing the shape of the gift shop. Now, for some of you older members or visitors, you may recognize the sign that says Discovery Shop. That was the name of the first gift shop back in 1991 when the Science Center opened. A few years after that, the building was, the shop was remodeled and they put a different wall in. So all the glass panels were taken out and put into storage. Well, when we decided to put the new wall into the space, Brian, our designer here, went, we got those glass panels that we can use. So we pulled those down. And if you notice, this one's upside down. Try not to pay too much close attention to that. We did fix that. But we were able to reuse the original glass panels from 91 in the new renovation of the gift shop. So it plays a nice homage back to the old gift shop. These glass panels were incredibly heavy. So multiple suction cups. And you can see we had 5 guys to lift these things up into place. This gentleman kneeling down here is Andy. He's one of our lead fabricators. Amazing guy. I'll get into that in a moment. While working on that, we had a movie premiere down in our Rangos Theater. So we had to drag our C-3PO and R2-D2 down from our Robot Hall of Fame down to the lobby. And it's always fun when you're taking these guys in the elevator, the looks you get from the visitors. So it's never a dull day at the Science Center. Each day is definitely unique. Also got to mention, I got to meet Anthony Daniels, the guy who played in the suit for C-3PO for almost all of the Star Wars movies. So that was really cool. So that brings me to RoboWorld, which again, another project concurrently happening with all the ones previously mentioned. And this was to create a drawing robot for RoboWorld. So it looks like a video projector, but it's not. There's an actual single beam laser, RGB, coming out, and then there's 2 mirrors and an X and Y axis that steer the light up and down and left and right to physically draw the image. Now it's doing that at 44,000 times a second. So you, through persistence of vision, see the completed image. Now that's not very fun, so I slowed the animation down here so visitors can see how it actually draws that image in a pseudo slow motion. So it's a neat drawing robot, so if you happen to be there and see it, feel free to mention to the other crew in your group just exactly how it works. So moving on from there, this brings me to my desk where I spent many late nights just staring at the code, just figuring out all the programming and interfacing for all these projects. Now, for those that are keen-eyed, you might notice down here, here's parts of the giant clock from the cafeteria. Now, I did a whole talk on that clock. It's about an hour long. It is, I'm proud of myself here, but it is a wonderful talk. It goes into the science, the makeup, kind of like we're doing here, of how it was built, how it was constructed, and how it works. So I have the code there if you want to click on that to check it out at a later time. I hope you can stay here and keep watching this. But if you like talks like this, let us know. And again, we can do more of them like that. This brings me to, again, exhibits in RoboWorld. This happens to be our large basketball robot. So I got tasked with replacing the aging one from 1996 with a new one. And this was quite a while before the button wall project, but we had to make sure the buttons, or excuse me, not the buttons, the bolts are all tightened up. So here we are checking the torque on 600 foot-pounds of bolts with about an 8-foot torque wrench. So every day, like I said, is an adventure. If you want to know more about the basketball project, that was a great adventure. Again, let us know. So at this point, I went on design reached under the table, grabbed the last piece of foam core, headed over to our fab lab and said, all right, it's time to actually figure out what this button wall is going to look like. Fortunately, Brian is a genius and he designed up a blueprint of what the wall was going to physically look like. He had to figure out the size of the buttons, the placement, how far apart they were going to be, aesthetics, what they were going to look like, how we're going to access it using the door there. Because being an exhibit, maintenance is always at the forefront of our mind. How are we going to keep it cool? How are we going to keep it clean? And how are we going to maintain it in the future? If things go bad, how do you troubleshoot it? So again, we work together as a collaborative process to figure all this out. So here we are putting that drafting into a program called vCarve. This is a software used for our CNC router at the Fab Lab, and it basically takes the CAD information and converts it to CAM. So basically it converts it to ones and zeros or movements in the XYZ coordinate for the CNC router to know where to go in the physical world. So being this the first time we ever used that software, and the Fab Lab at this point was fairly new, so it was, this kind of machine was still kind of new to everyone, we did something called an air cut. An air cut is the exact same code, we just move the Z height up a little bit so it doesn't touch anything. And this lets us know if the code's bad, something goes wrong, or it doesn't quite look right, or things are moving at the wrong feed speeds. Now, the material we use is something called birch plywood. It's a hardwood plywood with lots of laminations. Depending on the time of year, it can range from $300 to even $600 a sheet. So you don't want to mess it up. So we're doing this air cut to make sure that that all is going to work out well. Once we were happy with that, we placed the actual piece of lumber down, we crossed our fingers and watched and see what happened. So here's a time lapse of it going through and drilling all the holes. Now the fun part about a 200 button wall is it has more than 200 holes cut into it. Each button requires a set of indexing pins for holes. I'll get into that in a moment. So it's drilling all of those right now. And then after it finishes that, it's going to come back and drill the actual large hole in the center for the button body to go through. Now, what's fun about this was, as it's cutting those out, we didn't realize the diameter of that hole, the conflict it would have with the bit diameter, and sometimes they would jam. So you can see us here keeping an eye on it and making sure that the little slugs don't get stuck. And as you see it advance here, it's cutting out those larger holes in the middle. Now, a fun thing is it started going on. Again, this is our first time cutting a giant wall like this. If you notice here, all those slugs were light enough to get sucked up, but too heavy to go the whole way to the filter. So they're bouncing around inside the tube here. So we had to keep a close eye on it to make sure everything was doing happy there. And this is about the speed it actually operated at. Now, here's a close-up shot where it's doing the multiple ramps down, 1/4 inch at a time through the 3/4 inch material. And the last bit there, you'll see the little slug get sucked up. There it goes, up into the machine. Now, once that was done, this was the final result. And you can see here the large hole in the middle, and then the 2 indexing pins. Now I mentioned those because kids love to twist knobs and push, or excuse me, twist buttons and push knobs. It's even confusing to say. We have so many buttons that get twisted and it just twists all the wires out and causes problems. So the arcade buttons, they already thought of that. And there's 2 plastic nubs in the back that fit into these holes to keep you from physically rotating the button, which worked out really well. It just involves some extra drilling. And you can see on the left here, the completed design. So we held it up against the wall, grabbed a button, more nervous than we should have been because we did the math. We held up a button to see if it would fit, and it fit perfectly. So that was an exciting day when that worked out. So from there, it was time to cut the second sheet. Why a second sheet? Well, this is where Brian's years of material science comes in. He knew a giant 4x8 sheet of plywood, 3/4 inches thick, was going to be too flexible with that many holes in it from kids pushing on it. So we needed a second layer to double up those 2 3/4 inch sheets to give us the strength we needed. The problem was the buttons maximum can only go through a 3/4 inch piece of material because they're meant for arcade cabinets. So the second sheet here, we made the holes much larger to basically countersink the nut back in further to allow that to work with a thicker piece of material. We took both of those sheets and we sent it off to our fabrication shop. Now, our fab shop is located in the basement of the Carnegie Museum of Natural History. Again, a topic for another day, but if you want to see a video all about our fabrication and how we build these exhibits, let us know. We'll be sure to get a video on that. But what they did is they took our 2 doors, bonded them together, and then made the back box, again, out of birch plywood, to encapsulate everything and give it a nice, strong facade, if you will. It got bolted to the wall, and we even built these nice little jack stands, if you will, for the door to hold down because it's a very heavy door with 2 sheets of 4x8 3/4 inch birch plywood. So from there, we closed it up, took a look at it, and realized, well, we're going to need some buttons. Well, I placed a big order, and security hated me for a couple of weeks as all of these parts just kept coming in. Here's the 200 arcade buttons. We had to take each one of them, unbag them, unpack them, and put the LEDs in them. And it's hilarious how a simple task multiplied over 200 times really starts to get mundane. Well, we had to figure out at this point, how are we going to do the button layout? Now, originally we thought about doing a single color. And when we talked to the company, they're like, I don't have that many. So we got multiple colors, and even still, they had to pull them from multiple warehouses around the world to fulfill this order, because most people don't order 200 arcade buttons at once, plus 10 spares. So we had to figure out how we're going to do the color and button layout. And if you look on the left, that was one idea, doing concentric rings. And on the right, it looks random, but it's more of a diagonal pattern. Well, what we ended up going with is the diagonal pattern. It gave you some randomness, but still had a pleasing design to it. And this, again, where we work with our graphic designers as well to make sure things not only function right, but look good as well. So here we are putting the buttons in. Now, the funny thing about putting 200 buttons in a wall is, again, it gets tedious. I hate to keep repeating myself, but also complicated, because we have to reach, you're pushing the button in and you're tightening the nut down. Well, you can't reach around an 8-foot sheet of plywood. So what we did is we laid it down flat, and we had, you can see the shadow of the legs here, but we had an individual underneath the wall holding the buttons up, while a person on top, myself, was tightening the nuts down. So it was definitely a teamwork project. And we learned commands, like we're like, is it north, south, to like what button's going in, which one we're tightening. It was a learning curve. And we knew at this point, it was gonna be an interesting project. So at this point too, we were starting to get some murmuring from the night crew and security, wanting to know what this weird glowing apparatus was in the design suite. And I knew it was time to get this thing moved to the wall and start actually building it. So I packed up everything there, took it upstairs, and put it into the wall. So here you can see the ribbon cable laid out across the back, and then all those rainbow ribbon cables coming down, all broken off with a spade connector to get ready for their button. Now, if you look closely on this ribbon cable, you'll see it looks like a little notch in each one. Well, I mentioned exhibits are an iterative process. There's a lot of learning that happens when you're building one-off exhibits. Pretty much all of our exhibits are prototypes. If you think about them that way, is they're one-off and they have to work perfectly the first time. Well, when I widened that ribbon cable to fix one problem, I created another one. I started linking more pins on that Arduino. One of them happened to be the reset pin. Now, normally with that reset pin, you have to pull it down to ground to reset the Arduino. Well, because I wasn't doing that, I wasn't worried. Well, that length of wire kind of acts like an antenna, and it was randomly triggering the reset on multiple Arduinos by having it floating like that. So the quickest solution I come up with was to literally just cut a notch into the ribbon cable, which disconnected all the reset pins from all the other Arduinos, and all the random resets went away. Now, granted, this took a day of troubleshooting to figure out where this exact problem was. Once it's figured out, I knew the wall was going to be stable, and I can move on from there. So the process of building the wiring harnesses began. So here you can see the rainbow ribbon, cutting it down. You had a jig set up with markers, so I knew exactly how far to peel each one down, how much to cut it, and where to crimp the ends on. Now that brings me to another topic, crimping. The power wires, each button has 5 connections on it, because it has the LEDs, it has the switch, and then a switch leg that has to connect, and then those have to connect to a harness that has to connect to another distribution system. So there is a ton of ends that had to be crimped on. So fortunately, I ordered one of these pneumatic crimpers. So I spent a couple nights down in the Science Center's tech shop, which is located in the basement of the Carnegie Science Center. And the exhibit techs here were helping me by cutting the wire to length using a jig. And then here I am crimping the ends on for hours on end. The funny thing is, when you start working through late nights, just staring at a piece of machinery, you kind of start to grow an attachment to it. So this crimper and I pretty much go way back now. So moving on, I started getting complaints from the techs, just the fact of my wire droppings, they were ending up everywhere. So I realized at this point, I kind of need to start wrapping up all this wiring project. So I plowed through it, and here's the fruits of my labor. Actually, I say all of our labor. There was a lot of people who helped with this project. And these are the ends, the interconnects, the jumpers, and the switch legs all hooked up. So you can see here on the left, here's all the buttons, here's all the wires. Well, I need to connect them. Well, I need to keep track of what's going where. So I use something called paint markers. Some of you guys may be familiar. It's basically like a Sharpie, but it uses paint. So it's a very durable finish. And I use that to mark the wires. So I'm just going to remove myself here so you can see it. You can see the color code I did. So if something were to go wrong in the field, you're elbow deep in the wall, you can just look at the color and know where the wire came from. So you can hook it back up. Or if you need to replace a harness, it's a really quick swap out while they're in the field, so you don't have to take it down for long and you don't have upset children. So that was the process that worked into that. Now this was, I can't express the amount of help I had to get, because it was hand cramping. You could see all of this is 2 full boxes of buttons and wiring harness hooked up. And one thing I learned through the whole process is you can actually wear off your fingerprints. Who knew? This brings me to the world's largest power strip. I found this online. I didn't know you could order them this large. And on the right side is the power distribution harness. Now I'm using something called zip cord. Think of it like lamp cord or like Christmas light cord. It's a really simple two-conductor wire that you can use a connector called a vampire connector. It has like two fangs that pierce into the insulation to make contact in the wire, and then you put a cap over it to seal it. So that allowed me to take this harness, put a male plug end on it, connect it to this power strip that I used to distribute 12 volts, not 120 volts. So it was an easy way of doing mass distribution of power. And the cool thing about it is it gave me a fuse that I could put in there as well to protect the whole system. So that was a neat aspect of the project. I took that power strip, put it into the wall, and hooked up all the lights. Now you can do all the math, and I did, and I had an idea of how much power that power supply was going to need to draw for all these lights to power. But hooking it all up really gives you a good idea. So I got everything hooked up here, and you can actually almost feel the heat coming off from all the LEDs. But at this point, I knew my harnesses were good. I knew the buttons and the lights, everything was going to be good. So I needed to actually physically start doing it. So fortunately, at this point, or unfortunately, I got pulled away. Here's a behind the scenes look of our Point View Hall, which is our top floor special event space. If you ever had a wedding at Science Center, you've probably had it here. At this point, I'm working with the contractors on the layout of the projectors and the speakers. Now, because we didn't have those in-house and didn't have the space to test them in, we had to use a bunch of math with that. So we figured out the distribution rate of the cones and the horns on the speakers, at what height, how much coverage they would have, the projectors, at what spread or the throw ratio for the lens for the projector out, as well as the screen sizes and where they'd be at and what height and what visibility from different lengths. So we worked that out on blueprints and then went into the physical space, and we basically just pointed with a laser pointer and they marked on the ceiling where they wanted everything to go after we measured it out. So that was kind of cool work in that aspect. So we're doing a large scale speaker installation, at the same time we're doing a smaller scale button installation. So multiple skills passed amongst those. So at this point, I'm sitting there just wiring up the wall, and you can see I got the first 4 rows done here, and I'm using little zip tie landings, zip tying down. That was going really well. But once I got past 4, I couldn't reach anymore. You try leaning 3 feet past your feet and you fall over. Well, I had nowhere to put my hands. There was just too much stuff going on. So I came up with the idea of using an old piece of scaffolding, took the wheels off one side, dragged it over and plopped it down. And you can see on the right here, I'm laying on a small pillow. I was able to lay up there and put all these zip ties in. Now, fun story. About this time, we had a gentleman who wanted to volunteer at the Science Center in the tech department. Well, my boss decided it'd be great to have him help me with this project. So his first day volunteering, he got tasked with me to hook up these 200 wiring harness, zip tie them and clean them up. His name was Jeff. He was a wonderful guy, and he took this in stride. He loved it and wanted to do more. And he came back another day, and I'll show you later on that project. So I worked through getting these all hooked up. Now, I jokingly referred to this as my hell because I was dreaming of this at night. It was just the novelty of hooking up 200 buttons, making these all talk and all work. And if you messed up one wire, you could short out a whole system. It was just a path of learning project management more than any other project because you're managing 200 buttons and interfaces. So that's also meant a lot of late nights at home. Here's my home setup, doing coding because I wasn't distracted at home. People couldn't pull me away to projects while I was working there. But this brings us to the next morning. Here is the 4th floor space. We got the carpet down, exhibits are starting to get pulled in, and we're starting to figure out where everything is going to be placed. So this is dismantling the old ball factory to become the new tomato sorter, which you'll see shortly. So we're taking this apart here. And here is Jeff, I mentioned earlier, was volunteering to help. And with the exhibits, you can do the math, figure out the coefficient of drag, the parasitic drag of the tubing, the mass to weight ratio, how high a ball is going to travel given a current blower velocity. Sometimes it's more fun to just physically test it. So we attached the tubing to a scissor lift, and we just kept trying to push tomatoes through it and just kept lifting the scissor lift until they wouldn't come out anymore. That gave us our max head pressure that the balls of tomatoes could come out at. And that way we knew what we could do to design the exhibit around it. So this is worst case using the corrugated tubing, which has a very high parasitic drag that slows the ball flow down. So from that point, we tried other materials. We went with something called CPVC, which is a clear PVC tube. Holy cow, is it expensive, but boy, is it nice. We use it a lot in exhibits because you can see things moving through it, hence its name. So that was much smoother wall, so we didn't get as much drag, so it allowed us to travel things a little bit farther. So once we did all that testing, you'll see our fabricator, Andy, over here working on the water table exhibit. We were able to build the structure. So we have it all in place here. We relaminated it. The fabrication shop put a new laminate on to theme it to the area, and it is now the Great Tomato Sorter. So we knew how high that the tubes could go for the balls to travel down and go into the different areas. So it was a really fun iterative process of how it was all going to work. So exhibits, like I said, are very much a prototypical process of figuring out things as we go. So this brings me to another thing where we get to use materials in weird ways, and it's kind of fun. So here again, we have Brian, our lead designer. He came up with the idea of using, when you walk into a large walk-in freezer or cooler, those big flaps that seal out the outside world, well, you could buy those flap material, but they don't come in fun kelp colors like this. So he came up with the idea while working with our graphic designer, Azure, to send it out to have it direct printed. So on a giant printer, they printed this kelp green texture onto these large freezer flaps to use in the space. And we just used a razor blade to trim the bottoms to give them a kelp-like look, and put a grommet at the top and ran some aircraft cable up to a grid array to support all the kelp, to give it kind of like an enclosed feel for our underwater area. So we have our submarine in here, and there's certain things about a science center that are really amazing to us. You as visitors get attached to certain exhibits, and that's a great thing. You feel an attachment to them, and if they go away, everyone gets very upset. So the submarine is one of those. This has traveled from multiple exhibits, and it was originally created for Seascape on the 3rd floor, where we had fish and aquarium set up. So it now lives a happy new life as a reading nook up in our little underwater area. You can see the smaller kelp above, some bean bags to sit on, and a bookshelf inside. I'll get back to that area in a moment. Now, when you're designing and building an exhibit, you end up with a lot of late nights because you have a hard deadline and you're confronting problems as you move. So as you can see here, we're having a late night pizza. If you notice the Breadworks bag here, that was the bagels from breakfast. It was a lot of long days to make this all happen. Now, speaking of long days and late nights, lack of sleep, you end up with things like this. Sometimes you just have to laugh. Problems come up and you just have to move on and you learn from them. This particular one was a fun problem to fix. Now, while working on that, another side project we're working on was our Lego exhibit. This was part of our Lego exhibit we had in the traveling exhibit gallery. And we built our own interactive parts that now travel with that exhibit. One of those was a color tracking Lego music machine. So I have a CMU cam here that's looking at the color of the Lego. Once it picks out that color, it sends it to an Arduino that synthesizes a tone or a note on the musical scale to produce music. So if you were to lay out the Legos in a certain pattern, it would play musical notes. So it's a way of making musical Legos using color, which was a really fun project. Again, topic for another video. And if you look in the back, you'll see I'm testing the large clock for the cafe simultaneously. Now, speaking of simultaneously, this was another exhibit we're working on. This is in RoboWorld. The big rail-in pit in the back, that's something called a Styrofoam. Artist Ian created this, and it is a large robotic xylophone. Really cool project, but we needed to figure out how to lay it out because the wiring had to go through the floor. Well, the floor has joists in it. This particular area uses wood joists. So we laid out the joists with tape and used a video projector to project his image down on that floor in real time so he could adjust them so they wouldn't interfere with the floor joist and the wiring could all be clear. So this was a fun interactive process for designing the floor or designing the layout. So speaking of design, this brings me to the layout of the room and the look. So here is Dennis Bateman, our director of exhibits. He a lot of times gives us the big overall view of what he wants the space to be like. And here he is holding up an umbrella because he wanted umbrellas to hang above the water table. It's a really fun look. Well, here, Brian, our designer, he's trying to figure out how to hang those umbrellas to make it match that look. And I don't know if you've ever tried to hang an umbrella. It's not quite trivial. We end up using we use fishing line, monofilament, which is clear, and use it, a double triangle line to hang it so you can adjust the angle of the umbrellas to give you that cool look. Now, dusting them is a whole nother story, but they look really cool. Here's a view from the scissor lift up above, which most people don't get. I removed the safety chain here so you can look down. Here is the button wall all lit up. And you said you can almost feel the heat coming off from all those lights. So this brings me to the sound zones that I covered earlier. So I bought a bunch of PA speakers, like public address speakers with built-in amplifiers, put flying hooks into them. And these two went up in the ceiling. And then this is inside the submarine up in the sail. We put two little speakers in there so like sonar pings and bubble sounds play out through the inside of the submarine while you're in there reading. It's a really fun atmospheric effect. So this brings me to, we have an area we call the baby garden, which is a soft fabric area for young toddlers to play without worrying about falling or getting hurt. And it's a farm themed area. So we have a speaker hangs up there to play farm sounds like chickens clucking or hens and so forth. On the right here, this speaker, which I will remove myself from, hanging from the ceiling above the tree, you'll see another clip here, which goes the overhead sound for thunderstorms and things like that. So that brings me to the thunderstorm. Here you can see really awesome lighting effects. I have the flashing of the lightning and it interacting with the tree in the middle. So this happens when you press thunderstorm related buttons on the wall. Now you think of the a lot of times, oh, look how cool it looks. Well, it didn't start out that way. This is how it started. Now you can code something as much as you want. It's not until you physically try it out, you see what it actually does in the space. I use that DMX I talked about earlier to communicate with these studio lights that are in the ceiling to control them for the tree. So normally they're just on solid like a normal light. But when my button wall takes over, when you play a thunderstorm, it will flicker those lights and give you the thunder and the lightning to go together. Now, fun factoid, if you're ever in the space and you press the thunderstorm button, each one's randomly generated. So you get a unique storm each time, which is kind of cool. So that was that taking off. Now, the submarine area, we wanted a special effect as well. And I found this amazing projector on Amazon, of all places, that is a water projector. It uses an LED and 2 concurrent rotating lenses to produce this amazing water effect that I'll show you in a moment here, projects onto the submarine. So if you look up here, there is the projector shooting down onto the front of the submarine to give you an underwater effect on the cue from the button wall. Now again, another late night, more pizza later. This brings me to the wall lighting. So around the perimeter of the wall, I put in these smart addressable LEDs. Now, what I wanted this to be done for, which I will let this play here. Hi there. Is you notice the lights change every time you press a button? If you have someone who's hearing impaired, they get a visual feedback that the buttons are doing different things. So you can see that playing out here, and it just looks really cool. If you get a chance to ever play with addressable LEDs, I highly recommend it. You can address each individual LED, what color it is in the RGB spectrum and what brightness, all with code, which is just really neat. So that was me testing it. So here, this brings us to the final, quote unquote, final test. I have all the coding, I have the buttons wired up, everything's hooked up, and it's ready for public testing. So usually we get most exhibits to a stage, either it's a cardboard box or it's a more finished one like this, where we bring public in and they test it. They give us an idea of how visitors are going to interact with it, because we know from the start what it's going to do. They don't. And we want the visitor to come in fresh and have their own idea on what it should do. So here I am testing the wall for functionality. So I'll let myself take it over from here again.
Here, so now that the wall is mostly done, I just want to show you some of the cool stuff it does. So it's still 200 buttons with 200 sound effects. Hi there. That all play locally, and there's zones throughout the room. We have a tree here, a submarine underwater area, which you can see the wonderful lighting effects on the wall there. And then there's a garden in the back, or a farm area. So these all have different sound zones. So if I play something, I don't know, I think this one's a thunderstorm. The sound's playing above the tree at the moment, and there's lightning that'll come across in the clouds here, like so. And if I stop playing this here, you hear they're still playing behind me at the tree zone. There's other effects too, like the church bell that play at the tree and here, which is a really cool effect. There's some of the, I'm trying to remember where half of these are. I think it's, this one's a submarine one. So if I zoom in onto the submarine, you'll see the white, like water effect light on the front of it there. I'll do this again. Whoop. There you go. So there's a little projector in the ceiling up there that projects that on whenever you press a button that plays in the sound zone. There's farm ones, which they're here somewhere. Oh, there you go, chickens. There's no chickens playing in the farm area over there. So lots of fun. There's also interactive stuff, like this one does bubbles. If you watch over there, bubbles come out of the wall. How fun is that? And if you press again, you'll get more bubbles. That's the bubble button. And then this is the shutdown button. So if a kid presses this one, whole wall goes dark. Give it a few seconds, turns back on. And it also controls the light in the ceiling too. So that turns everything off. So it leaves the lights on in the back though, so kids don't get scared. There's another one here, this one. That will do a ball factory. We have there, I'll open a dump bucket on it. And there's a few other things I'm sure I'm missing, but that's the outside.
So that is another one of those videos I would share with the group, just to where we are and how the project's working. So at this point, I was riding high. I'm like, this is great. Let's bring the kids in and see what happens. Well, the first group of kids that came in, first thing they did, both hands, mashing buttons, just simultaneously. And then there's even kids too, who just find one button and just keep hitting it over and over and over again, to the great dismay of the presenters in the space, might I mind. So at this point, I knew some adjustments to the code I had to make. So what I did was this. Try another button.
One button at a time works best.
So if you notice here, I created the code to look at all the buttons. And this is where not using a matrix came in, because if one kid's in the corner, just keep mashing one button, it shuts the lights off and says more than one button works better. And if you're just mashing multiple buttons at once, it shuts all the lights off and says try one button at a time. So it knows how the wall's being used, and if it's being abused, to let kids learn on their own task and own merit other things that they can do on the wall or try other buttons. So this is part of our design process that we do with a lot of our exhibits. We test the public, see what changes can be made, make the changes, and then do more testing. And it's really fun too, because you never know what a visitor's going to do. I remember my first exhibit, I was still a youngin' at the Science Center almost 16 years ago, and I was designing a winch system for an exhibit for a mobile, and it had an up and a down button. Got it all built, very proud of it. We opened it up. First kid came up and hit the up and down at the same time, shorted it out, and blew the circuit breaker. Those are the things that you learn with experience. Why would a kid hit up and down at the same time? You don't think of it that way. Think of it as how can this thing be interact with differently than what you're thinking and account for it. So I designed it so when one button's pushed down, it removes power from the other button, so both push down won't do anything. So those are the things you learn as you work in exhibits, which is really fun. So this brings me to the wall. At this point, I pretty much have everything wired up. You can see the master Arduino here with the display, and then all the sound zones all labeled for the different areas, and then the LED controller and the relays at the top. Now, a fun little hack I did is I wanted to control these lights. Well, with all exhibits, you really run into a time budget. It had different dynamic modes that by hitting the mode button would just cycle through them. So I just soldered to the button and ran to a relay. So the relay just hits the mode button every time you press a button on the wall to give you visual feedback. So that was a very quick way of interfacing with a more complex piece of electronics. The DMX runs up to the room and goes through different relays, one to control the bubble machine, one to control the light above the submarine, as well as some of the other DMX lights in the ceiling. The audio travels via audio ball-in. It's basically a balanced transformer that sends the audio over a network cable to long stretches across the room where the amplifiers are located and the speakers for the different zones. So that was the inside wiring with a little fan to keep it cool. And at this point, usually we start getting the graphics involved. So Azure, our head artist and graphic designer, created the text panels for our exhibits. So she came up with these to put on the space. Normally we have a lot more text, but because this is an early learner space and well, it's a button wall, we didn't need a whole lot of instructions. So you can see it covers up the panel on the left there and gives you some instructions for the kids to use. Now, I want to give you some quick stats. I'm not going to read through all of these, but when you start doing a project this size, it's kind of amazing how these things add up. 210 button harnesses. There's over 2,520 paint marks. There was 1,908 wire terminations, all done by hand. A crazy amount of wires. 6 Arduino Unos, 21 Arduino Nanos, 27 total Arduinos, all communicating happily to each other. 203 MP3 files, because it has those startup sequence I explained earlier. 4 sheets of 4x8 birch plywood. We have 8 DMX strobe lights. There's 800 feet of Cat6 cable that runs all around the room for all the interfaces. 5,400 watts of power used by the entire system, including the remote devices and lights. 270 screws, 500 zip ties, 96 feet of ribbon cable, and the door alone has over 80 pounds of electronics, buttons, wire, and wood in it. So the stats are kind of impressive when you sit back and look at how crazy that is. But that brings me to the grand opening of the early learner space, or we call it the Little Learner Clubhouse. Now, this was our press preview. So we opened it up to the public to come in, and we usually do member preview nights. So if you're not a member, make sure you become one because you get access to these early events like this. And here we are with an overhead view of the space. So I'll try to walk you through it. On the right is a free learn area, which I am blocking with my head. There we go. There is a blue blocks area that allows free play. To the left of that is that farm area I had mentioned with all the soft padding and soft animals for kids to interact with. And next to that is the submarine book area. Here is, I jokingly refer to it, the tree of knowledge, because it has little shelves with puzzles and games and learning things you could take out to the picnic tables and play with as individual area, learn a particular topic and put it back and move on to the next one. We have our water table in the back with little hooks to hang your aprons. And then there's a slate wall that's on the side, allows you to draw on it using water, which is neat. There's the button wall, of course, and then the tomato sorter on the side. And then the thing I'm standing on is the large play structure that allows kids to run around and see all this. So this gives you an overhead view of it. Here we are after the event is over, and you can see some of the tomatoes got spilled. The button wall was such a huge hit. The kids fell in love with it. Adults even just sat there and just wanted to know what every button did, wanted to hear every sound. The kids were also amazed when they pressed a button and something happened somewhere else in the room. The best part was the first 2 kids that came in ran up to it and then stopped and just stared at it. they didn't know what to do. No one has seen that many buttons. Like, I mean, just imagine to a kid what a wall bigger than them full of buttons is like. That joy right there is what makes all the late nights and all the work that we put into it worth it. It's that inspiration, that wow, aha, that makes the Science Center so great, that brings these, scientific topics to the kids in ways that are easy to understand, which is so much fun. But not only did the visitors here like it, the news seemed to pick up on it. So here, Pittsburgh Paper ran an article about the button wall. And on the left here, for those who are into electronics and DIY, Hackster ran an article talking about the button wall and how it worked, which was really cool. And it didn't stop there. Adafruit, the company who made the sound modules that I use for the wall, they put on their blog everything about the button wall, which was really cool. So visitors to their site can learn about this really cool project. It even got picked up internationally. Here happens to be a French site, Mekabe Le Blog, that a gentleman took my video I did explaining the wall and translated it, took screen captures, and broke it out completely so other folks who don't speak English could learn more about how this project worked, which was really cool. But what really blew me away was when I discovered this post by Pete, who happens to be the co-founder of the Pi Foundation, or the Raspberry Pi, that a lot of guys may be familiar with, the little microcomputer that sold so well. He retweeted the project, which is really cool. Well, to give you all filled in, it probably brings you to a point now where you either you're completely lost or you have a lot of questions. Well, I'm more than happy to answer any of these questions. And for any reason you do not get your question answered tonight, or just don't want to ask it in a public forum, here's my contact information. So feel free to reach out to me. I try to answer them as quickly as possible, but a lot of times there's a large volume. But yeah, feel free to reach out to me. I'm happy to answer any weird questions you may have related to what I do, how the Science Center works, the behind the scenes, or even about an exhibit you didn't hear about or want to know more about. Feel free to let us know. From here, I will let Lamont take it over and we'll start the Q&A section. So thank you all very much for watching. This was a wonderful opportunity. I look forward to doing more with you guys.
First of all, Doug, wow. This is really awesome. There's so much work in science and technology and engineering and math that goes into exhibit design that until I heard you kind of connect all the dots in that way, I never really thought about. And I definitely want to give a big shout out to the design team in general. So Azure, Ryan, yourself, Dennis, you guys are the umbrella academy of the Science Center, and you have like superpowers that you guys put together to use science for good. So that it's so cool. We do have a couple of questions here in the chat, so I will read through some of those. So the first question we have here, someone asked if you can talk about some current projects that you're working on right now.
Sure. Boy, there's so many. I'm working on a micro mill, so I'm building my own CNC machine. I managed to get access to a defunct scanning electron microscope. For some reason, I only allowed about 90% of it. So I took as many parts as I could. Well, part of that was the sample manipulator that's basically accurate to one atom to move the sample around. Well, I built that into a micro milling machine that's accurate to 1 micron. So I could basically engrave on the side of a human hair, which is really fun. I'm buying bits that are so small you need a magnifying glass to see the tip of them. And it was fun learning it because I'm reaching the limits. I was using something called GRBL, which is an open source CNC software you can run off an Arduino. I'm at the limit of the software running that small of accuracy. So I had to do a scale of 10. So the software thinks it's 10 times bigger of a machine than it actually is, which was really fun. I'm also working on a really high power laser. It's about 300 watt ND YAG laser that I'm replacing the deuterium rod inside of it and trying to get that up and running. But I always have so many projects in the works. Again, feel free to ask me about any of them and I can be happy to talk to you, but I don't want to waste all the time talking about those today, but good question.
Yes, I will waste all your time asking you about all your cool projects at a later date, but we'll get to some more questions. One of the questions that's popped up a few times was, how many hours did it take to kind of complete this entire project? Did you keep track, or do you have an estimate of about how many hours from design, kind of conception and implementation did it take?
That is a very good question. Normally with being pulled away on so many side projects, it's hard to keep track of what an actual timeline for one project is. Usually we keep track of for a whole exhibit. The best estimation, because I've been asked this question before, is probably around 500 hours. A lot of that went into the programming and the design process, which is a little bit slower than the actual fabrication. Fabrication was all pretty much completed, installed, and running within a month.
And so a similar question to that was, how many hours of code did it actually take for you to kind of put all this together?
So coding, it's always funny. You can't think of it linearly. The running joke in programming is you have 99 problems and can't find one. It's so much iteration. You're creating and recreating and testing and doing different things. The recent project I did for an outside museum, it was an interactive room, about the same amount of Arduinos, was 14,500 lines of code added up across all the Arduinos to make that work. So that may give you a glimpse as to how this all worked. The giant clock I did, that one had multiple nested arrays to keep track of all the pixels in real time so it could cycle through them within a second. So let's just say coding is a very fluid process that takes a lot of iterations to get right.
And with all the coding that you had to do, what button would you say was worth all the coding? What button is your favorite button?
Oh, my favorite button. Oh, man. So I loved the bubble button just for the fact it's so unexpected. You press it, and all of a sudden these bubbles just start coming out of nowhere from the wall and falling down. Second best, maybe by the thunderstorm, just because I spent so many sleepless nights creating the code for that dynamic thunderstorm, and just seeing the result in person is a really cool effect.
Nice. And bubbles are generally awesome, so there's that as well. Here's another question that I actually wanted to ask you. And the way it's posed here, so it says, for students who might be interested in your position, what's your educational background, both formal and informal? But I also want to expand that beyond students. If you were an adult and are just kind of really interested in what you do and how you connect STEM, what advice would you give, and kind of what background do you think someone would need to kind of be prepared to do what you do?
That is a fantastic question, and it'll come with an equally fantastic answer. Education is very tricky because, like I said, mechatronics is a fairly new field. When I was growing up and doing education, a lot of that didn't exist. I know right out of high school, I got hired into a robotics company, and I was working on building mobile robots for home. And that part, I realized at that point I was learning so much in the field. After about a year of college, I discovered that I was learning more doing my jobs in the field than I was in school, because school had a hard time keeping up at that point with how quickly technology was changing. So the nice thing was school gave me the foundation to learn these aspects, the science, the math, and the technology, to learn how to learn, if you will. And then from that point on, I took jobs that would teach me things I wanted to know. I'd work in engineering, I'd work in art, I'd work in places, the things that I wanted to know more about. And that landed me a job at the Science Center. I was working for a different robotic company, and we got hired in to build an exhibit. And while I was at the Science Center, I fell in love with the place. And I applied, and of course the position in my standing at the points that I didn't have a college degree didn't immediately get me into a position. So I started from the ground up. I worked as a volunteer. I worked as a volunteer for almost a year, and then I worked my way into a presenter position and learned the exhibits by just interacting and presenting them with visitors. And from that point, I basically earned my merit by studying up and learning through my other jobs. At one point, I had 4 jobs I was working simultaneously because I just loved the different technologies. And at that point, I learned enough and built enough muster that I could interview for the tech position, was able to get that. Worked my way through the tech position and kept learning more and worked my way into AV. So I took an AV position as an AV specialist at the Science Center, worked there for a few years. And at that point, I was able to slowly kind of create a position that didn't exist, and that was mechatronics. Because the design department at that point was just building the exhibit and making it look pretty. There wasn't a whole lot of computerized interfacing going on inside. So I taught myself how to do software, how to create my own programs, how to interface with Arduinos, which at the time were basic stamps and PICs. Just basically taught myself at home these things with the wonderful resource the internet is, and was able to get myself into a position where I am now that I could do these things. Now, about education. If you work differently than me, which most people do, education, you want a well-rounded application. So a lot of colleges now do offer a course in mechatronics, but you want to learn manufacturing science, material science. You want to learn software. You want to learn how coding works. You don't need to be an expert coder. You just need to understand the concepts of how for loops work, how, you look up into an array for information, how the math in coding works. There's so much math in coding, but don't let it be intimidating. One thing that's wonderful about the Arduino that I love is the community. If you don't know how to build something, you can reach out to one of these local forums or groups, and someone will either help you write the code or give you a direction and way you can do it. I can't tell you how many exhibits that we found code that someone graciously has given us that they've already created that works for a lot of what we do, and we just modify it. Like I said, you don't have to always reinvent the wheel. So if you are interested in these topics, It sounds silly, but start at the internet. Type in what you're interested in and start looking up videos. There are tons of people out there who do amazing tutorials, intro videos to just learn these projects. And from there, you got to tinker. You got to get your hands dirty. I have a lab in my basement just for experimenting. I built my own RC lawnmower. Why? Well, they're expensive to buy and I wanted one, so I built it myself. I found a scrap electric wheelchair and pieced it together and used RC controls from an RC car and built it into a lawnmower. So those are the things you learn by doing. And I can't stress enough how much it is important to just get your hands dirty and try these things. So I hope that helped answer your question in a very long-winded way.
Absolutely love that answer. Just kind of getting your hands dirty and kind of leveraging the technology that we have to use the internet to teach yourself what you don't know, that you want to know, and kind of starting there and then volunteering and kind of, getting yourself experience and putting it all together and being able to not necessarily start with a formal education, but be able to do something that people who come right out of school may or may not be able to do if they didn't follow a similar path as you, to kind of fit all the moving pieces together all at one time. So I think that is a really awesome answer and great advice.
And I'll jump in real quick here. One thing I forgot to mention was it doesn't really take money to pay to play, if you will. MIT offered a lot of their electronic courses for free online. You could just watch their YouTube videos of the courses. And I learned a lot of really advanced electronics by watching those videos without having to pay to take the course. So you don't get the accreditation, but you get the knowledge that allows you to work better into projects.
Yeah, thanks for sharing that. That's a really great resource. Just kind of speaking of trying to be Doug, the wizard that you are, you said that you ordered a bunch of these pieces from Amazon. How feasible would this be to do a button wall or something similar to this at home?
So I believe that entire button wall could be built from Amazon at this point. It is incredible. We don't use Amazon for any particular reason. It's just that they happen to have a majority of what we need. They ship really quick. We use Adafruit a lot. I love supporting that company. Lady Ada, who created it, is an inspirational story. A female entrepreneur created this electronics company. Highly recommend them. They make amazing products and really good libraries to go with it. I don't know. I kind of lost track on that topic. Can you help me out here, Lamont? Sorry. Oh, I may have lost there for a moment. Basically, if you want to build a project like this at home, look on eBay. There's a lot of people who look at things called, there's an old hackster called Obtainium, which is basically scrap stuff. So if you're young and new into this and you don't want to buy new stuff, a lot of times you can go onto resources like Craigslist or eBay and find places you can find free stuff locally. Get your names in the hats. I know I got my names in certain places that they call me up and go, hey, we're getting rid of this piece of equipment. Do you want it before it goes to the scrapyard? Absolutely. It may not work, but you can take it apart, pull capacitors out, pull motors, pull bits out. I mean, you can build a CNC machine from DVD players using the stepper motors out of it. There's so much you can build from just stuff you can get free. I highly recommend reaching those opportunities. But if you do want to buy stuff, Amazon and eBay are a great way to start. They're good pricing at the time to get onesie, twosie kind of stuff. When you get into production, you can look more into Mouse or Jamco, those bigger companies, but that should give you a good start.
That's awesome. So that was actually just my question. No one submitted that. I am going to try to do that, and I will be asking you for tons of help. But we do have a couple of more questions here. We have a 3-part question. The first part is about how many times does the button need to be pressed before it will shut down?
Oh, I'll start with that one. So that one, believe it or not, is dynamic. It's how many buttons have been pressed in a certain amount of time. I didn't want a hard variable because kids are really smart and they would pick up on that and they would start exploiting it. So the unit itself looks over a chunk of milliseconds. And if it's gotten multiple inputs from either a single button or multiple buttons, that's when it triggers the different loop to trigger that output, if you will.
And then so, why would you have the whole wall shut down instead of just a button that goes dark for a few seconds?
So we did a trick here to basically have all of the button lights individually turn on and off would involve a set of output devices, almost 200 other relays and a ton more wiring. So I kind of cheated. The switch we're using has 2 poles into it. It's a single throw double pole. So it switches from a normally closed to a normally open contact. And I wired the light through that. So when it's sitting in the normally closed position, the light is on the button. And when it goes pushed down, it disconnects the light and sends the ground connection to the Arduino to read the input. So I'm kind of cheating there. The reason I couldn't shut off individual lights is because I physically can't. I'm actually turning the ground off to the, or 12 volt off to the entire wall, which turns off all the lights to the button. So that was my kind of workaround to make that system work.
Great. And what was the name of the company that made the buttons again?
Oh, SUZO, it's Suzo, HAP, H-A-P-P. You can buy them buttons on Amazon, one's a two, but if you buy them directly from HAP, they do have a minimum order because they expect you to be ordering it like an arcade, needing large buttons. So just a heads up there.
Cool. And then, so what will happen if one of the buttons burnt out?
Oh, good question. So in the entire time it's been installed, we've only had 2 buttons go bad, believe it or not. And those were mechanical failures. The actual plastic cracked, and it could just been a manufacturer defect. When that happens, the button, you twist, pop out the whole module, harness included, remove the plastic button, put it back in, and then click in the new, or click the button back in, it's ready to go. It's a really quick system to troubleshoot and service the wall.
Very cool. Another question we have, someone asked, would you say that the wall was built primarily for entertainment, or was there a defined learning objective from moving into it?
So dealing with early learners, sometimes they learn things that don't seem like big topics to us adults. So just having them push a button and get a sound back, that's a connection. And by having them push another button and having something happen somewhere else in the room, they see that the world is bigger than them, because younger kids, their world kind of exists close to them. And things that happen outside that bubble, they don't realize they're controlling. So this is a way of kind of helping spread their horizons, if you will, to learn more, and just having the sounds of the world be played in there. So there's farm sounds, thunderstorms, there's pigs, there's voices, there's burping. These are all things that can be used as learning opportunities by the adult who's with them to explain what these sounds are and where they come from. And it's just a neat way that the kids can learn in an informal way.
Great. So another comment that we have received a few times is a request to know where your other behind the scenes videos, where would someone may find them. And I think that there's a demand for maybe even a series of kind of the development behind our favorite exhibits.
Absolutely. So we don't overwhelm my social media. I think we'll start with maybe looking at options to pass this through the official means of the Science Center. So for now, if you reach out to my email address, which I should be able to put back up here, you can reach out to me and I can send you a link, onesie twosies, to get you into the behind the scenes, the stuff I do. And then from there, we can work on more official means.
Thank you. Like I said, everybody, the more kind of feedback that we get, we can maybe turn this into a little bit more of an official series, a spin-off series, if you will, because I'm personally really interested in how all the moving pieces work. Some of the things that I see every single day that I've never really thought about the mechanical, or how all of the pieces work together to make it work. So another question that we have is, how were the sounds and interactives selected for the wall?
That is a fantastic question. So something as simple as just finding sound seems very mundane, but it's quite a complex process. We have a large group of people who help us develop exhibits outside of design. So we have accessibility task force that makes sure that what we're doing is easily accessible by people with disabilities and is easily workable by people of all sizes, shapes. And one of the things with is sound is these sounds can't be scary. They can't be anything that would interfere, harm, or scare any individual or offend. So what we did is we subscribed to a sound site, Storyblocks, and they have millions of sound effects. And we all just picked ones we liked, grouped them all together, and then we set them to the multiple groups. Do they meet an educational goal? Are they safe? Are they not scary? Do they meet ADA guidelines? Those kind of things all help narrow down that selection to end up with the 200 we have. Fun story was, it was such a whittling away that we ended up with a few buttons we didn't have sounds for. So we ended up just making those numbers 1, 2, 3, and 4 so the kids can learn to count. So that was a fun workaround for that.
So one of the reasons why I was probably not included in that process, because I would request Fleetwood Mac to be played on one of the buttons. I don't know if you can easily make that happen for me one day, but that would be sweet.
That was the other thing, copyright. We had to worry about copyright.
There it is. There's always a reason, right? Another fun fact, so these videos were actually uploaded into the Science Center social media pages. So if you had any questions and you kind of wanted to rewatch it and digest it again and then send Doug an email, feel free to do that. Just a general comment that someone left, Doug is a treasure. The Science Center is so lucky to have him. I would totally agree. He is a total treasure and wizard. Wizard is just the word that comes to mind. The things that he's able to do, I think are really, really, really cool.
Thank you. I appreciate that very much.
All right, so I think we got through most of the questions here. If for whatever reason I missed your question, like I said, please feel free to follow up with us. We also just want to get your general feedback about how our first virtual Cafe Sci went. If you had any ideas about how we can improve it, I certainly will make sure I have a better microphone next time. That was some of the earlier comments that we had. So thank you for bearing with us throughout all of that.
You just need a microphone that works like this and you'll be fine.
Nice. Again, total wizardry. So if you are interested in another kind of awesome presentation, next month we'll have another speaker. Like I said, it's on the first Monday of every month. I want to thank you all for tuning in. I also want to thank our sponsors again, PPG and Cocomyosite. I want to give a special thanks to Kara Fiske and membership. She really helped set all this up for us. Kara's awesome. So if you want to become a member of the Carnegie Science Center or any of the Carnegie museums, feel free to go to any of our websites and you can find access to our membership and you can sign up online. We also have another program, virtual program for our adult crowd at the end of this week on International Beer Day, which is this Friday. We will be partnering with Easton Brewing for an event called Science of Beer. So we'll be kind of hanging out with some of our favorite local brewmasters discussing the science of beer, and they have a specialty brew pack. We're going to do a virtual mini beer fest, beer tasting, if you will, and so you can buy the different brews and we'll taste along with the different beers. So that is something fun that's coming up that you can learn more about on our website as well for our adult audience. And so after you have a couple of beers, maybe you'll be seeing Doug in that light. But yeah, so check out our website for our next Cafe Sci for more exciting lectures from the Carnegie Science Center. And before I go, we got one more comment that came through, and it was just really another thanks and saying that they enjoyed the video and they're interested in how the future of these web series progress. So thank you so much all for tuning in, and we'll talk to you soon. Go Science.
Thank you, everyone.
Thanks again, Doug.